In this presentations, we are going to discuss about the disk structure in operating system. The disk structure, it is a drive and it is addressed a large one-dimensional array of logical blocks where the logical blocks is the smallest unit of transfer. The low-level formatting creates a logical blocks on physical media. The one-dimensional array of logical block is mapped into a sector of the disk sequentially. The sector 0 is the first sector of the first track on the outermost cylinder. So the mapping process is proceed in order through that track, then the rest of the tracks in that cylinder, and then through the rest of the cylinders from the outermost to innermost. The logical to physical address should be easy. So it is an except for bad sector, so non-constant of the sectors per track by a constant angular velocity. The disk attachment. So here the host attached storage access through IO ports taking to IO buses. SDSA itself is a bus up to 16 devices on one cable. SDSA initiator requests operations and SDSA targets perform task. Each target can have up to 8 logical units. The FC is a high speed serial architecture, so can be switched the fabric with 24-bit address space. So the IO directed to bus ID, device ID, logical units. The storage array, so it can just attach disk, array of disk. So it is used for the storage. Okay, so it is an array of disk. The storage array has controller, provide the features to attached host. So here the ports to connect host to array, memory controlling software, a few to thousands of disks, then RAID host spares host swap, then the shared storage, it is a more efficiency. The features are found in some file system. So in the storage area network, common in large storage environment. So in this multiple hosts attached to multiple storage arrays, where the SAN is one or more storage arrays connected to one or more fiber channel switches. The host also attached to the switches. So the storage made available via LUN MOS from the specific arrays to the specific server. Easy to add or remove storage and new host and allocate it storage. Then why have separate storage network and communications networks? So if we consider the SZSI FZOE, so it is an essential. Then the network attached storage. So in this NAS is a storage made available over a network rather than over a local connection. So it's a remotely attached to file systems. So the NFS and CIFS are the common protocols. So it is implemented via remote procedure calls, and the ICSI protocols use IP network to carry the SASI protocols. So in this, the interconnections of this LAN WAN with this storage device, that's an NAS and the client access. So in this disk scheduling, the operating systems is responsible for using a hardware efficiently for the disk drives. So this means having a fast access time and disk bandwidth. So it is a minimize the seek time. The seek time is in seek distance. So the disk bandwidth is the total number of byte transferred divided by the total time between the first request for service and the completions of the last transfer. So where there are many sources of the disk IO request, there's an OS and system process and user process. So in this IO request includes the input output model, disk address, memory address, number of sectors to transfer. In this OS maintains queues of the request per the disk or the drive. The ideal disk can immediately work on IO request. So busy disk means work must in the queue. So The device controller is essential. So the device controller have a small buffers and can manage the queues of the IO request. Several algorithms exist to schedule the servicing of the disk IO request. The analysis is true for one or many platters. So we illustrate the scheduling algorithms with the requesting of queue. The first one is FCFS. So it illustrations shows total head movement of 640 cylinders. So the queue, it has the process 98. So in this SSTF, it's in shortest seek time. First select the request with the minimum seek time from the current head positions, where is the form of SJF scheduling may cause starvations of some requests. So the illustration shows the total head movement of 236 cylinders, and in this scan structure, the disk arm starts at the one end of the disk and moves towards the other end. So serving request until it gets to the other end of the disk. So where the head movement is resolved and servicing continuous. The scan algorithm, sometimes called the elevator algorithm. So the illustration shows the total head movement of 236 cylinders. But note that if requests are uniformly dense, largest density at other end of disk and those weight the largest. So this illustration describes the head start at 53, the queues in this form, then the C-scan algorithm. So it provides a more uniform wait time than this scan that moves from one end of the disk to the other. So the servicing request as it goes when it reaches the other end, however, it immediately returns to the beginning of the disk. So without serving any request on the return trip. So in this C-look, so look is the versions of the scan and scan. So where the C-look is the versions of the C-scan. So here the arm only goes as per as the last request in each directions. Then reverse directions immediately without first going all the way to the end of the disk. Total number of cylinders. Here the starting head is at in the 53, then the process are going. So in this selecting a disk scheduling algorithm, so is a common and has a natural appeals. So in this scan and C-scan perform better for the systems that places a heavy load on the disk, but the performance depends on the number and types of the request. The request of the disk services can be influenced by the file allocations method. The disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with the different algorithm if necessary. So in this disk management, low level formatting or the physical formatting. So it's a dividing a disk into a sectors, that is a disk controller can read and write. So to use a disk to hold files, the operating system still needs to record its own data structures on the disk. So it has three key aspects, that's in partitions, the logical formatting, clusterings, and the raw disk access for applications that want to do their own block management, keep OS out of the way. So the boot block initialize system, so the bootstrap is stored in ROM. So bootstrap loader program stored in boot blocks of boot partitions. So the methods are such as sector sparing, so uses to hold and handle bad blocks. So booting from a disk in Windows. So many portions of the data are available. So in that time the first booting is stored into a ROM. So in this SMAP space management, it is a virtual memory uses disk space as an extension of main memory. So in the SMAP space can be curved out of the normal file system, or more commonly it can be in a separate disk partition. The SMAP space management 4.3 BSD allocates swap space when the process starts and holds the text segments and data segments. The kernel uses a swap max to track a swap space users. Solaris 2 allocates swap space only when a dirty page is forced out of the physical memory, not when the virtual memory page is first created. The data structures of swapping in Linux system. Then RAID structure. So in this RAID, RAID, redundant array of inexpensive disk. So here the multiple disk drives provide reliability via redundancy. So increases the mean time to failure. So it has to maintain the mean time to repair, mean time to data loss, and the frequently combined with NVRAM to improve write performance. And several importance on the disk use technology involves the use of the multiple disk working cooperatively. So disk stripping uses a group of disks as one storage unit. The RAID is arranged into 6 different levels. So the schemes improves the performance and improve the reliability of storage system by storing redundancy data. So it's also maintain the parity of checking. So here the block interleaved parity uses much less redundancy, and the replications and hot space performance is improved the reliability in this storage. The RAID levels are described level by level. The strip, each strip is increased in this ascending order. So in this follow up is done with the single disk failure. Then other features are, it has the snapshot, is a view of the file systems before a set of changes takes place. The replications is automatic duplications of writes between the separate sites, and the hot smart disk is unused, automatically used by the RAID protections. If a disk fails to replace the failed disk and rebuild the RAID set if possible. Then its extensions, that's a better improvement for the existing versions. It has the checksum. So it is an for the verifications and the protections is done by that checksums. The transmitting data is clearly verified by the checksum process actually. So in this checksum kept with the pointer to the object to detect if the object is the right one and whether it changed. So for the protections purpose. So in this checksum for all metadata and the data, so the data are combinedly transmitted. So in that time each data checksum is transferred with the, its address and its checksum value. So the data are combined and that is to be separated, that checksums, and that checksum value is also calculated in receiver side. So when that is matched with the receiving checksum and the calculating checksum, so it is accepted. Traditional and pooled storage. In this stable storage implementations, so write ahead log schemes requires stable storage. To implement a stable storage, replicate information on more than one non-volatile storage media with independent failure modes. So the update information in the controlled manner to ensure that we can recover the stable data after any failures during the data transfers on that recovery. So we have to maintain the main three things by using the stable storage, the successful completions, the particle failures and the total failures to be reduced. So if the failure occurs during the block write, recovery procedures restores block to consistent state. Thank you.